Hello students, welcome back to my YouTube channel Data Shah. I have started a new series, probability distributions, in which I'll be talking about various discrete probability distributions and continuous probability distributions. So this is my first lecture, and in this particular lecture I am talking about random variables. So what is a random variable? What are the different types of random variable? So we'll be doing that. So let's start. A random variable, it's a function that assigns a real number to each outcome in the sample space of a random experiment. So basically, a random variable is denoted always by an uppercase letter like capital X, capital Y, whatever is given in the function, or if you assumes, we always take it as a capital X. The values of a random variable are real numbers, like it could be 0, 1, 2, 3, or it could be 1, 2, 3, or it could be 3, 4, 5. So it is always denoted by a small lowercase letter like x, small x is equal to 0, 1, 2, and so on. So we have to remember the notations here that random variable is always denoted by capital X. For example, I'm taking a random experiment of tossing of two coins, and in this, I will define the random variable capital X as the number of heads. So, if I'm tossing the coins, two coins, then the number of heads, what would be the possibilities of the number of heads occurring? Now, it could be, I will be writing this as capital X. It could be that I'll get a zero head. Zero head means, like, for example, in the sample space, I'm getting both tails. So that means there is zero head. Then it could be possible that I'm getting a tail and a head. Then in this case, how many heads can you see? One. The another possibility is the first one is head and the other one is tail. Then again, the possibility is one. And lastly, it could be that I am having both the heads. So there are two heads occurring in this. So capital X, as you have just seen, are the values x is equal to 0. So this is basically my small x. X is equal to 1, x is equal to 1, and x is equal to 2. So in the sample space, I have all the four outcomes, like both the tails, both the heads, either a head or a tail. So this is basically represents my capital X. And the values of a random variable is denoted by the small x. So moving ahead, let me tell you the various types of the random variables. Now, the various types of the random variables are, first is discrete random variable. So discrete random variable means a random variable in which can take only finitely many values. So for example, if I'm the above example that we could see, the tossing of two coins, that is a discrete random variable example. And also, when you are drawing three cards from a back of playing cards, the random variable would be the number of kings drawn or the number of queens you are drawing. So that becomes a discrete random variable. Continuous random variable would be a random variable if it can take any value between the certain limits. That means when we are talking about the intervals in which there are infinitely many values. So for example, height, weight of the students, this or I can talk about the prices. So it comes under the category of the continuous random variables. So let us move ahead, and in today's class, I'll be talking about the discrete random variables and its various definitions. So I'll be taking few examples as well. Let x be a discrete random variable, assuming the values x1, x2, x3 up till xn corresponding to the various outcomes of a random experiment. If the probability of occurrence of x is equal to xi is p of xi, which can also be written as p of I ranging from 1 to n, such that the sum of the probabilities is equal to 1, then the function pxi is called the probability function of the random variable x, and the set is known as the probability distribution of x. So moving ahead, the probability mass function. Now, what is a probability mass function? It is also known as mass function. Now, when we are talking about the probability mass function, we will consider for a discrete random variable I'm talking about. So let me just write it. It is a function. Mm, It satisfies the following conditions that we have. So the first condition would be that the probabilities are greater than or equal to 0. So here the first condition would be P of xi's are greater than equal to 0 for all I. So our I is going from 1 up till n. So it has to be greater than equal to 0. Second condition is the summation of all the pxi's has to be 1. So again ranging from 1 to n. So if these two conditions are satisfied, then we say that the pxi that we are talking about would be the probability mass function, or PMF, or just you can say a mass function. So let us consider one question in which we need to check whether the so let me just write, verify the following function is a probability mass function. So let me take fx for small x is equal to 0, 1, 2, 3, and 4. So here this is our fx. Now it depends upon the question. If they have given fx, so we'll be considering that. If they would have given p of x, we will consider that. So it won't create a difference. So this is the first part, and we'll be doing the various part after this. So let us just complete this. So the answer of this would be, we need to check the two conditions here. So as we know, the probability, we need to check whether it is greater than or equal to 0 or not. So let us consider from the function, I can calculate a table. So okay, let me just quickly make a table in which I am talking about the x and fx. So the various values would be 0, 1, 2, 3, and 4. So 0, 1, 2, 3, 4. So when I put x is equal to 0 in f of x, so it would become 1 upon 25. So I'll just substitute the values. When you put x is equal to 1, it becomes 3 upon 25. And similarly, put the other values and we can calculate f of x for each of the values. So this is now as I have just told you clearly, x is a discrete random variable. So here f of x are greater than equal to 0 for all the x when we are talking about it as 0, 1, 2, 3, 4. Um, small x. Now we need to find out what it would be the summation of fx, where we have x going from 0 to 4. The summation would be f of 0 plus f of 1, f of 2, f of 3, f of 4. So let us write down. This would be equal to 1 upon 25, 3 upon 25, 5 upon 25, 7 upon 25 plus 9 upon 25. As the bases are same, so we can quickly calculate it. So 7 plus 3 is 10. 9 plus 1 is again 10. So plus 5 would give me 25 upon 25. That is 1. So clearly I could say thus the given function is a probability mass function or a mass function. So I'm just using the abbreviation PMF. Now, the another part that we have in this is that you need to find P of x equal to 4. P of x less than equal to 1. C, and lastly the D part where we are talking about greater than minus 1. So how to find the answer here? So let's consider the first part, that is A. Because this is a x is a discrete random variable, so P of x equal to 4. From the table, we can easily calculate that this is nothing but this f of 4. So I can write this as 9 upon 25. Now the B part states P of x less than equal to 1. Less than equal to 1 means all the random variable, the values of the random variable, which is less than or equal to 1. So here you will see that the capital X has only two values, 0 and 1 in this case. So I'll be just writing here, this would be equal to P of x equal to 0 plus P of x equal to 1, which is nothing but f of 0 plus f of 1. So this is from the table 1 upon 25 plus 3 upon 25. That's 4 upon 25. Now the next part, P of x lying between 2 and 4. So, but one thing you need to focus here, that x is greater than equal to 2, but strictly less than 4. So again, this means you will consider 2, but you will not consider 4 here. So P of x equal to 2 and only x equal to 3. We can't take P of x equal to 4 because here is a strict inequality. So this is nothing but f of 2 plus f of 3. So from the table, this is 5 upon 25 plus 7 upon 25. That's 12 upon 25. Lastly, we have P of x greater than minus 1. Now in the table, you will see that the capital X values are um, 0, 1, 2, 3, and 4. So we don't have any negative values here. But understand here they are asking us x, capital X greater than minus 1. So as you could see, all of these values are greater than minus 1. So this is nothing but equivalent of saying P of x equal to 0, P of x equal to 1, P of x equal to 2, P of x equal to 3, and P of X equal to 4. So this is the sum of all the values, and as we know, it is equal to 1. So P of X greater than minus 1 is nothing but equal to 1. So this is how we can calculate the all these parts, and this is very easy to calculate. Now, one more term that is quite often we use in discrete random variables is cumulative distribution function. So let me just write here cumulative distribution function. Yes. So let's talk about cumulative distribution function now. A cumulative distribution function of a discrete random variable x is defined by capital Fx. So it is defined or denoted by capital Fx, which is equal to P of x greater less than equals to small x. That means I can say summation if I'll take f of x size, or p of x size if I'm taking the values. So this is nothing but where x size are less than equals to small x. Whatever small x you have, it is given to you. Now, there are certain properties of fx that we need to understand. So let me just take the various properties. So the first property is that fx always lies between 0 and 1. This is true because it has to be greater than equal to 0, because the probabilities are always greater than equal to 0. And why it is less than equals to 1? Because when you are calculating the distribution function, so the distribution function of the last value, that means of capital X, would be equal to 1. So you would notice that there is all the elements would the distribution function would lies between 0 and 1. The second property is if we have any x less than equals to y, then the f of x is also less than equals to f of y. So let us just take one question related to the distribution function. Verify that the following function is a cumulative distribution function, and determine the probability mass function where the required probabilities are so we need to verify that this function is a CDF. and you need to find out the required with the required probabilities. We used. So let me just write the whole question first. Now, to verify whether it is a CDF or not, we can clearly see that the fx is lying between 0 and 1. And if x is less than equals to y, that means we are talking about 1, 2, and 3, or 1 and 3. So their fx is also less than equals to f of y. So clearly we could say that this is CDF. So let me just write the answer here. Clearly, fx lies between 0 and 1, and both the properties are satisfied. So the reason that we get here is this is because fx is p of x less than equals to x. That's just the summation of the probabilities. So now how we'll get the determine the probability mass function. Fx is a CDF. Now, how would we calculate the probability mass function? Now, what see the breakpoints. The breakpoints are x less than 1, x lying between 1 and 3. That means you need to figure out the probabilities at 1 and 3 only. So in the probability mass function, your capital X has only two values, that is 1 and 3. So how would we able to find out the value of it? Now here you would see that X less than 1 is 0 and X greater than equal to 1 is 0.5. So that means if we are talking about X equal to 1, so that's nothing but 0.5 minus 0. And when we are talking about x equal to 3, so then we'll subtract 1 minus 0.5. So let me just write it here. Now, the probability mass function is given by p of x equal to 1, that is 0.5 minus 0, p of x equal to 3, that is 1 minus 0.5, which is again 0.5. So the only points that we are considering here is 1 and 3. So these would be their respective probabilities. So if you want to make a table, you can create a table as well. So this is how it would look. X and P of X. So when your X is equal to 1, it is 0.5. When X is equal to 3, it is 0.5. So this is your probability distribution table. Now we have found the PMF. We have verified that it is a CDF. Now we need to find out these three parts. So let us consider it one by one. So in the first part, we need to find out P of X less than equal to 3. So that means that's nothing. But according to the CDF, this is F of 3. So F of 3 is 1, as we could see in the question. The second part that we have is p of x less than 2. So strictly less than 2 would again be we are talking about only 1. So this would be p of x equal to 1, that is equal to 0.5, because x less than strictly less than 2, we have only one random variable value, that is 1. Now, when we talk about the last part, which is p of x greater than 2, so p of x greater than 2, here we'll be talking about 1 minus p of x less than equal to 2. So less than equal to 2, this is nothing but f of 2. So what would be now our f of 2? F of 2 is nothing. If you'll put, if we talk about here, then this would be equal to 1 minus 0.5. Why 0.5? Because here you could see in the question that x lying between 1 to 3. So in the x, it can take the value 2 as well. So f of x is 0.5. So if I'll take 2, I'll give small x the value 2. So f of 2 is nothing but 0.5. So this becomes 1 minus 0.5. So again, the answer would be 0.5. So this is how we can find out the cumulative distribution function. Verify that this is a cumulative distribution function. I'll take another small question of the previous question that we have already taken, that we have already created the sample space. So of a fair coin, which is tossed, a fair coin is tossed twice. Let x, capital X, denotes the number of heads. Find the CDF. So in this particular question, you need to directly find out the CDF. So as we know, the sample space I have already created above would be both heads, head, tail, tail, heads, and tail, tail. So this is very easy to find out. Let X denotes, capital X denotes the number of heads. Now, as we could see, we could create the probability distribution table quickly, in which we can find the values. So this would be x, and this is my p of x. So as we could see here, so as above in the above question, the number of heads. So number of heads could be 0, it could be 1, and it could be 2. Now, when it is 1, as okay, as it is 1, as it is 0, so 0 means we are talking about this, where it has, we are having two tails. So in this case, what would be my probability? Probability would be half of tails, half of tails. That means 1 upon 4. Because we know the probability of head is half, and that is the probability of tails as well. Now, when we are having head, one head, so we have these two cases. So again, it would be if first is head and the second is tails. So I have taken this particular case here. Now, the other is also available, where the first is tails and the other one is heads. So what will happen in this case? The probability of tails into the probability of heads. So that's nothing but 2 upon 4. Then it is coming 2 heads. So that's obviously the probability of head, and the probability of head, that is 1 upon 4. So here you could check that the sum of all the probabilities is equal to 1, and the probabilities are also greater than equal to 0. So it's certainly a PMF, right? The probability mass function. Now, if we talk about CDF here, so as we know, the CDF, that means fx, is P of x less than equals to the small x. So let me just define it quickly. For x less than equals to 0, then for x less than equals to 1, and lastly, for x less than equals to 2. For x less than equals to 0, there is nothing less than 0, but equal to 0 is there. So I'll just write it 1 upon 4. X less than equals to 1 would include 0 and 1, both the cases. So I'll just add them up. So it becomes 3 upon 4. And x less than equals to 2 will include 0, 1 and 2 together. So this is nothing but 1 upon 4 plus 2 upon 4 plus 1 upon 4. That is 4 upon 4, which is nothing but 1. So as I just explained you in the starting, that in the CDF, whatever you have the last value of your capital X, it will always come equal to 1. So this is how we can find out CDF and the discrete random variable probability mass function and the CDF questions. So in the next lecture, I'll be talking about the continuous random variable and its related questions. So do subscribe to my channel and like this video, share this video so that we can connect more. Thank you.